Okay, dear students, let me summarize the learning of previous lecture before going to what kind of things we are going to discuss in this lecture. In previous lecture, we have discussed how to choose a neural network, because that is very, very important, and we have discussed that the topology of neural network and structure of the neural network will depend on the problem set, or the problem for which you are going to design a neural network. That the kind of a problem will decide, the type of the problem will decide the structure of neural network. Then in previous lecture, we also discussed about the activation function. What is the need of activation function? What kind of a different activation functions are involved, and in which situation, which kind of activation function can be used. Today we will discuss very, very important topic, training of artificial neural network. So let me, before starting formally the lecture about training of artificial neural network, let us discuss the scenario, the learning of a child. I think all of us have seen we have a siblings, or we have seen the childs, how the childs grow, how child learn, and I think we all of us remember little bit our journey also when we were kid. So if you see the kid, let's say a 6-month kid is there, and how the kids learn. Children are learning from their parents and from the environment. Children are not only learning from their home, in their home, and from the parents only. There are different environmental parameters also there, so those are affecting the learning of the child. When we are saying artificial neural networks, the same analogy we can establish between the learning of a child and the training of artificial neural network. Some learnings the child takes from the parents also. Some learning child takes from the environment also. And if you remember your childhood, sometimes parents are also not available, environmental factor is also not available. Then what we do? If we have a new situation, we do the experiment on the environment. We do the experiment and we analyze the result. So if broadly we can categorize these kind of a learning is, in one kind of a learning, parents are available, and in another learning, parents are not available, but environment is having some set parameters. Somebody else have seen the problem earlier. On the basis of that, we can learn something. The third situation, parents are also not available, environmental factor is also not available. Purely we are, as a kid, we are doing experiments. And by doing experiments, we are learning. So I think I set the agenda of today's lecture, training of artificial neural network. So we established an analogy between the learning of a child and the mathematical models. All right. So these are the today's content: training of artificial neural network, supervised learning, unsupervised learning, reinforcement learning, and at the last we will see the learning rules, the mathematical models of learning. Okay, so let's see the formal definition of the learning. The formal definition says neural network has to be configured such that the application, a set of input, produces the set of desired input. What is the meaning of learning? Very simple. If you are supposed to perform some activities as an input, you can establish the activities with the analogy between the activities and the input. So you are passing some inputs. On the basis of inputs, you expect some output. So your neural network, or let's say discuss a child, how child learn. We can see if we are teaching a student the alphabet or the numbers, or we are teaching that this is a fan. So slowly the child learn this. There are numbers, there are alphabets, and this is fan also. So slowly child moves from remembrance to generalization. The same thing happens over here. So we are passing some inputs, and output of those inputs are known. Then the desired output is expected. If the desired output is on the expected lines, correct, then we say that the artificial neural network is trained well. Otherwise, more training is required. That's why in earlier lectures we were discussing that some childs have a very good IQ and they learn very fast. But some of the childs take some time. So that is how the same thing is in case of neural network also. Sometimes neural network get trained very fast, and sometimes neural network takes time to train. All right. I hope I make the point clear. There can be various methods, as I was discussing about the child's environment is there, parents are there, and both are absent. So there can be various methods to train the neural network. Also, we will see one by one. Okay. Let us discuss first supervised learning. It is also called associative learning. As name suggests, supervised learning. The supervised comes from the supervisor. So as this is a very similar analogy, the child is learning from the parents or child is learning from the teacher in classroom when he or she is going to the school. So it means, what is the meaning of the availability of the supervisor is there. The supervisor has capability to analyze the input, and the supervisor also know what kind of a input for what kind of particular set of input, what kind of a output is expected. So supervisor have a prior knowledge of output of the certain pattern. So in case of supervised learning, we have a large training set is available, in which what kind of a training set is available? Input pattern is there, and for particular set of input pattern, output is known. And that training pattern is passed to the neural network, fed in the neural network. So now the neural network get trained for a particular set of inputs, and it try to achieve the expected output. For example, if there is a difference between the expected output and actual output, we train neural network again, till we are not getting a minimum error. I am not saying that zero error, it means the complete. Now what happens? Let's say at a particular point of time, we are passing hundreds and thousands of training patterns to neural network, and we feel that now error is optimized. We reach some certain threshold or equilibrium, we can say that, mapping between input samples and the target variables. So now what happens? We pass to check that the neural network has been trained correctly. What we will do that? We will pick up certain input patterns for which the output is not known. Then we will pass the input and we'll check that for the new inputs, what kind of a behavior is there for a neural network. If it behaves correctly, it gives you expected output, then we say that now our neural network is trained or getting trained or near to trained. So let me summarize this topic again. What is the meaning of supervised learning? This picture will give you the more. See, this is a neural network. And this is supervised learning. Supervisor is available. So neural network is getting trained. If it is committing a mistake, for example, in classroom, I am giving you a numerical, and if you are not able to solve the numericals, as a supervisor, as a teacher, I am available to guide you. So that is the meaning of supervised learning. So here, the output for input patterns is known, supervisor is available to make you correct, to minimize your errors. So that is the meaning of supervised learning. Let me give you one more example to make the concept very clear. Classification. And we can discuss regression also. So I think with the classification you are more comfortable. What is the meaning of classification? Classification means the large number of parameters are there and you want to put those parameters into different class. So characteristics of that class, the characteristics of that group is also known to you. And as per the characteristics, you can put different values as per their characteristics in different groups, and those groups will be called classes. So here, in case of classes, supervised learning problem that involve predicting a class level. So supervised learning, we can say that it is also very, when we are, how it is useful, when we are doing classification, then supervised learning is very, very useful. So here it is very important to discuss the difference between the classification and clustering also. Then the next concept will be easily understood by you. In case of classification, the parameters, deciding factors are known. In case of clusters, when we are doing clustering, mathematically or theoretically, whatever, then the grouping parameters are not known. So how the clustering will take place? In both the case, in the classification is also grouping, clustering is also grouping. But in case of classification, the grouping parameters are known on the basis of that which we are making a group. But in case of classification, let's say 2-3 samples are coming. On the basis of samples, we make them in different groups on the basis of their parameters. And the next parameter is coming, next value is coming on the basis of the association between the parameters of the new value and the value which we received earlier be put in the same group or the in different group. So the parameters are not known in prior. While we are doing grouping, we are analyzing the patterns and we are putting in a different groups. So that is make the clustering. So clustering is example of unsupervised learning. Supervisor is not available. The output of patterns is not known. All right, supervised learning. So next kind of learning is unsupervised learning. In case of unsupervised learning, clustering is a fine example of unsupervised learning. The supervisor is not available. Okay, just see here. Unit is trained to respond to cluster of pattern within the input. In this paradigm, the system is supposed to discover statistically salient features of the input population. So here, when input population or set of pattern is there, in case of supervised learning, the output is known. In case of unsupervised learning, or you can say clustering, the output is not known. We are analyzing the features of the patterns. On the basis of their features, we are putting in different groups. When the next pattern is coming, we are seeing that to which kind of a group it is matching more, and we are putting that new pattern into particular group. So here supervisor is not available. Neural network is doing the grouping on the basis of features of the patterns. Unlike the supervised learning paradigm, there is no prior set of categories in which the patterns are to be classified. There is no prior knowledge available, as I was discussing with you. In unsupervised learning, there is no instructor or teacher is available. That's a fundamental difference. So when you are committing a mistake, you are learning by yourself. You are analyzing your patterns and you are committing a mistake. On the basis of the error, you are adjusting your group. Alright? So let me summarize the supervised learning and unsupervised learning. In case of supervised learning, the output of patterns or the supervisor is available. In case of unsupervised learning, that facility is not there. Clustering is example of unsupervised learning. Alright? So Hebb's learning rule, let us understand this mathematically. What it says? It says that the first learning rule was introduced by Donald Hebb. His basic rule is if a neuron receives an input from another neuron and if both are highly active, what is the meaning of highly active is mathematically they have a same sign, positive or negative. If they have a mathematically same sign, the weight between the neurons should be strengthened. Right? So what formula says? The change in weight will depend on the input pattern. Xi is ith input pattern and Oi is output of ith neuron. Let me clear it. His delta omega represents change in weight. Xi represent ith input pattern. Oi represent the output of ith neuron in a neural network. And how we can calculate Oi? It is f of net I. F is what? Activation function. Net I, you know that we have discussed that neuron is nothing but it is summation of it's a summation element. So what it is doing? It is summing what? Input pattern and output for that respective input pattern. Xi, omega I. So there may be 2-3 input patterns also, and they will have a corresponding weight. So here what will happen? How we will calculate the f net? It will come x1 omega 1 plus x2 omega 2 plus x3 omega 3 and so on. So once activation function is applied, you can calculate OI, output of ith neuron, and that will give you the change in weight. So Xi is particular input pattern and OI is output pattern of the neuron. The Hebbian rule represents a purely feed-forward and unsupervised learning. So this statement gives you the idea where we are supposed to apply the Hebbian rule. For applying the Hebbian rule, we have to design our neural network in a feed-forward manner, and the learning should be unsupervised. Alright? In the state that if crosses the product of input and output is positive, if Xi or OI is positive, it means the increase in weight. If it is negative, of course, there is a decrease in weight. I hope the Hebbian learning rule is clear to you. Next is perceptron learning rule. Let us discuss this one. How we will apply the perceptron learning rule? First of all, initialize the weight at random. You may select the weight 1, 1 also. Omega 1 is equal to 1, omega 2 is equal to 1, omega 1 is equal to 0, and whatever. Random weights can be selected. Once you selected the weight, then we will calculate the output of the neuron. The output of neuron will give you the actual output for a particular input pattern. And if you already know the output for that particular input pattern, then that will call a desired output. So now you have a two output, desired output for a particular input pattern and the actual output which you are getting from the neuron. Once you have a desired output and actual output, then you can create a difference, calculate the difference, it will give you the error. So here, target of perceptron learning rule, we will apply the perceptron learning algorithm till we are not minimizing the error. What is the meaning of minimizing error? The difference between the actual output and desired output. Alright. For each training pattern, Xi is a training pattern, and this training pattern has corresponding desired output, right? Where Di is a desired output. We will compute the output of a particular neuron, same way we do in the Hebbian learning rule, right? And we apply the activation function also. Once we calculate the actual output and we also have a desired output, we will compute the error. Error will be the difference between a Di and Oi. It will give you the error. So use the error to update the weights because our target is to minimize the error. So perceptron learning rule gives the change in weight formula is neta, this is learning rate, this is error, and Xi is a particular pattern. So now new weight will be what? Old weight plus change in weight, where neta is called learning rate or step size, and it determines how smoothly the learning process takes place. Now we'll repeat the step 2 until the error is not minimized. Let me summarize again this rule. First of all, you will choose the random weights. Then you will have a pattern of what? Input pattern and desired output for a particular input pattern. And you will calculate the actual output for a particular neuron. And once you calculate the actual output, you will calculate the error. Then you will calculate the change in weight by applying the perceptron learning formula, this one. And you can adjust the weight accordingly. Till time you are not minimize the error, this step number 2 will be repeated. That is how algorithm will function. Okay. Dear students, that's all about today's lecture. Let me summarize again. What was the learning of today's lecture? We learned the different learning methods: supervised learning, unsupervised learning, reinforcement learning, and we discussed the difference between these three. And we learned two learning rules also: Hebbian learning rule as well as perceptron learning rule. And in which kind of situation we can apply which kind of a learning rule. In next lecture, we will apply these learning rules on simulate the different gates, AND gate and OR gate, XOR gates. Okay, all right.